Hello everyone, this is Mohan Karthik. Today I am going to tell about a topic which is spelling correction, fuzzy search, and edit distance in information retrieval. Let us go into the topic. Here, when users enter wrongly word, then it is the responsibility of information retrieval to detect those errors and it has to fix those errors. Here, IR uses three techniques. One is spelling correction, fuzzy search, edit distance. Let us go to spelling correction. Spelling correction means it automatically detects and fixes the wrongly entered words by the user. Fuzzy search. Fuzzy search means when user enters a query, if that query does not matches with the stored words, then it will give result even if the query does not matches with the stored words. Edit distance. Edit distance is a mathematical measure used by information retrieval to find the similarity between two words. Let us say there are two strings S1 and S2. It will find the similarity between edit distance between those two strings. Let us go to each topic one by one. Spelling correction. Spelling correction means it automatically detects and fixes the error when user enters wrongly words. There are two types in it. One is non-contextual spelling correction and contextual spelling correction. Non-contextual spelling correction means it will does not see the context. It will be used for single word error correction. For example, receive. Receive is wrongly treated, so it will replace the I with E to become receive a correct word. Now let us see context spelling correction. Context spelling correction means it uses the surrounding words to predict the correct word. For example, I went to see. Here, went is something which is used for a place. For example, here see is a place. So both are valid words, but here the word went is used for a place. So the context helps to select the C. Let us go into the next topic, which is edit distance. Edit distance is a mathematical measure used to find the similarity between two strings, or we can say like it is the minimum number of operations to convert a string S1 to S2. In edit distance, it uses some common operations: insert, deletion, substitution, transposition. Insert means adding a character. For example, spelling. Here we have inserted a character L to become correct word spelling. Deletion. Deletion means remove a character. For example, in the word committee, we have removed the letter T to become a correct word T. Here we have deleted a character T. Substitution. Substitution means replacing one character with the another character. For example, receive. Here we have replaced I with E to become correct word receive. Transposition which is optional in many forms, but transform means swapping two adjacent characters. For example, here H is swapped with T to become correct word the. Here edit distance follows these four operations, and for a string S1 to transform into S2, here we use these four operations. Let us see the common types of edit distance. There are three types. One is Hamming distance, Levenshtein distance, Damarov-Levenshtein distance. Hamming distance. In Hamming distance, operations allowed are substitution. For example, 10101. Here we have replaced 1 with 0 to become correct word 1001. Here we have performed one operation. So the edit distance will be 1. Levenshtein distance. The operations allowed are insertion, deletion, substitution. Here, kitten we have replaced K with S, one operation, and we have replaced E with I, another operation, and we have inserted a character Z, that means another operation. So here the number of operations are 3, so the edit distance becomes 3. Damarov-Levenshtein distance. Here the operations allowed are insertion, deletion, substitution, transposition. Insertion means adding a character, deletion means removing a character, substitution means we can replace one character with another character. Transposition means swapping two adjacent characters. Here occurs is a word. Here we have deleted a character S to becomes occurs. So the number of operations performed are 1, means the edit distance will be 1. These are three common types of edit distance. Now let us see what is the importance of edit distance in information retrieval. Edit distance, it is a measure used to find the similarity between user queries and the stored words. Stored words means indexed words in information retrieval. Let us see some uses of edit distance. Spelling checkers. In phone keyboards and search engines, they use spelling checkers to correct the wrongly entered words by the user. Autocorrect. Search engines like Google, Brave, those uses auto correction to correct the wrongly entered words by the user. Plagiarism detection. Two documents will be there. Those similarity score will be calculated to find the plagiarism detection. DNA sequence matching. Let us see fuzzy search. Fuzzy search means when a result, even if the query does not matches with the stored data, it will give some result. Those are called fuzzy searches. How it works? It will compute the edit distance between the user entered query with the stored data, means the indexed words. And these edit distance will be find for each query with the stored data, and returns the item with a distance which which is below the edit distance, or we can say otherwise like it will return the items whose similarity score is greater than the threshold. Let us see next slide. The approaches used to fuzzy search. There are three approaches. One is edit distance, n-gram matching, phonetic matching. Edit distance means it will compute the Levenshtein distance for each word. It will compute the edit distance between the query and the stored words. Here in edit distance, there are three types. One is Levenshtein distance, Hamming distance, and Damaru-Levenshtein distance. You can use any of the three to find the edit distance, and these edit distance will be sorted, and the spelling correction will be predicted. Now let us see n-gram index. N-gram index breaks the words into overlapping parts. For example, here hello is a word. Here we have break the hello word into HELLLO and compare those words similarity scored by Jocon similarity. Now let us see the next type, which is phonetic matching. Here the matching words which are similarly sounding using the algorithm like SoundX metaphone. For example, query environment. Here the fuzzy matches for environment are environments, and envelopment. Let us see the applications and importance of fuzzy search. Search engines uses fuzzy search. For example, search engines like Google, which uses fuzzy search for retrieving the results. And if a user enters a query, it will uses fuzzy search to get the best results. Text editors like WPS, keyboards in smartphones, and Microsoft uses these fuzzy search to to spell check and autocorrect. Databases uses fuzzy matching in SQL queries. Natural language processing, cleaning noisy text before analysis. It uses fuzzy search for this purpose. Let us see the flow, how the fuzzy search happens. When user enters a query, it will generates candidates with edit distance less than 2. Here 2 is the threshold kept by the system. It will keep a threshold which is less than or equal to 2. The words with edit distance less than or equal to 2 will be retrieved and ranks them by frequency, and the system predicts the spelling correction. Now let us see the code. Code.py to run the code. Here it asks a word. Let us enter banana. Here we enter a wrong word. Then it will predict the correct word banana with edit distance as 1. Let us enter another word. Let me run the code again. Let us enter apple with only 1p. Here the code predicts it is as apple and edit distance as 1. Let us see the code. Here, edit distance function will find the edit distance between word entered by the user and the words in the dictionary. Here, string 1 represents the word in the dictionary and string 2 represents the word entered by the user. N is the length of the string 1, M is the length of the string 2. Let us initialize a DP which is of size n plus 1 cross n plus 1. Let us see the base cases. Here the base case is, if string was 1 is empty, then it requires I number of deletions to make it as empty, and it requires j number of deletions to make it empty. And let us fill the DP. Here we require two for loops because the DP we have taken as 2D matrix, so it requires two for loops. And here there are two conditions. One is, if the characters between the two strings are equal, then we will take the previous values. There is no operation performed here. If the characters are not equal, then we have to perform either deletion, insertion, substitution. If we perform any one of the operation, so we have to add 1 to it, and the answer will be present in dp of m cross n. Now we have initialized a list which contains the dictionary words and correct spelling. It will iterate over the each word in the dictionary, and it will find the minimum edit distance between the each word in the dictionary with the word entered by the user, and it will suggest a word and with the minimum edit distance. And here are the main codes for user to enter something. First, it will ask a word to enter by the user, and it will predict some edit distance, and it will predict a word which having minimum edit distance between the word entered by the user and word in the dictionary, and it will predict the edit distance and the corrected word. Thank you.